All of you, welcome to my first video lecture on signals and systems. Signals and systems. Okay. First, I'll see the introduction for signals and systems subject. For that, I'll see first what is a signal. What is a signal? Signal is any physical phenomena that carries information. Any physical phenomena that carries information. What are the examples? Our speech signal, music signal, ECG, electrocardiograph, means which is related to the heart, then image or photo, video, etc. All these are the examples of signals. Take the speech signal or voice signal. See, I'm now taking the class. This is my voice signal. Speech signal, it carries the information that we want to convey. Music, it carries the related information of music. It carries the heartbeat, or it tells us about the heartbeat. It carries the photo, and it carries photo plus audio. Okay, these are all some examples of signals. Okay, the signal is generally represented by x of t. In our signals and systems, it is represented by x of t, where t is called independent variable and x is called dependent variable. T, what is t? It is time. Okay, so in signals and systems concept, okay, the independent variable is time and x depends on the independent variable time, and the value of x of t value is called amplitude. This amplitude varies with respect to t. Plot of amplitude with respect to t gives you waveform. Okay, suppose take this signal, normal your sinusoidal signal. Here it is represented by x of t and this is represented by t. Okay, so this is called sinusoidal waveform. Okay, same way speech is having some shape, music, ECG, image and video all are having shapes. Take x of t. This signal varies with the variable t only. That's why it is called one-dimensional. 1 dimensional signal. one-dimensional signal. Some signals are there which varies with two variables, x comma y. Then this is called two-dimensional signal. Two-dimensional signal, the example is image. And now you may have one doubt. You are saying it is image, but you are writing it as under the signal. Image is a signal. Remember, image is a signal. Image is a two-dimensional signal. Okay. And another one, v of x comma y comma t. What is this? This is a three-dimensional signal. Three-dimensional signal. It is nothing but your video signal. Video is also a signal. Okay. And this is a three-dimensional signal. This is all about the signal. It carries information. And these are the examples. And this is the representation. And this is the waveform definition. This is the example. And these are different types of signals with respect to their dimensionality. And coming to the system concept. System. What is a system? Simply, it processes the signal or it modifies the signal. It modifies the signal. Means, suppose if it is a system, if we give input signal, I'll get some output signal. This output signal and input signal are not alike. The system will modify the input signal according to our requirement and it gives out that processed or modified signal. Okay, so this is the definition of system. What are the applications of signals and systems? Or what is the objective of the subject signals and systems in electronics and communication engineering? It is not only having the applications in electronics and communication engineering, it has many applications in other areas also. Okay, just let me explain about our electronics and communication engineering. Application. Okay. See, what is a communication system? What is a communication system? Yes, it has a transmitter, it has a receiver. Between these two there exists a lot of free space, so antenna is needed. Okay, this is transmitting antenna and this is receiving antenna. Now, want to convey any information or want to send any information, let be input signal. It may be your speech signal, any video signal, it may be text, etc. Okay, these are the forms of input signal. After giving this input signal to the transmitter, transmitter will modify your input signal. Your transmitter will consist of many things. Transmitter will consist of transducer, first transducer, second amplifier, third some frequency selective network. The signal first it goes to the transducer. Suppose yes, we imagine that you're sending a speech signal or voice signal. This transmitter block simply consists of many electronic components or many electronic circuits. But here the input signal is speech. The input signal is speech signal. It is not in the form of electrical. So now give the speech signal to the transducer. Now your transducer converts this speech signal into electrical. Okay. So transducer is a system. Now that this electrical signal is given to the amplifier. What is the work of amplifier? Amplifier will increase the amplitude of the signal. Then that is given to the frequency selective network. It selects the required frequencies. That is given to the transmitting antenna. Okay, here not only is a frequency selective network, here we have modulator also. After the modulation and frequency selection, that signal is given to the transmitting antenna. Now this transmitting antenna will convert electrical signal into electromagnetic signal. See here how many conversions are there for our signal. Initially, we are giving a speech signal that is converted into electrical, that gets modified or amplitude gets modified or increased by the amplifier. Then that is given to the frequency selective network along with the modulator circuit. Then modulator circuit will modulate your signal and frequency selective network will select the required frequencies. And the output is not like this signal. And that is given to the transmitting antenna, which converts your electrical signal into electromagnetic signal. And that gets radiated into free space. Okay. This signal gets received by your receiving antenna. Exactly the opposite will happen in receiver. Okay. Receiving antenna converts electromagnetic signal into electrical signal. The first stage is demodulator circuit or frequency setting network. After that, the signal is given to, if at all needed, for any amplifier, or if not needed, no need of any amplifier. Then suppose if it is speech, then what should be the output of receiver? It should be the output, last block of the receiver must be a speaker. Okay. Then up to this is all electrical signal in different forms, and from this it is sound. See the setup. We have many signals and we have many systems. So this is the best application of the concept signals and systems. Okay. Not only in a communication, the signals and systems concepts are very much useful in biomedical applications. I think you know the ECG, EEG, EMG, etc. All these are biomedical signals, can be processed with their respective devices. Then in signal, image and video processing. Different signals related to the atmosphere, different signals related to the geology, astronomy, all these signals gets processed using systems, separate systems. Even the photos, images are processed using different camera systems, okay, and also the videos. Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.